In the third example, we're going to solve these two simultaneous equations. Now, straight away, if you have a look at what we've got, you notice that they're different to what we did in the last two. Looking at the four terms with x and y in, none of them have a value of 1. So we don't have a 1x or a 1y anywhere. So here's a different method, which is called the method of elimination. And basically in this method we are going to eliminate, get rid of, one of the variables before we can move forward. Now notice that we have 7x here and 2x here. We've got 2y here and negative 3y here. What we're looking to do with the method of elimination is to try and get these numbers to be the same. So we could have, let's say, 10x here and 10x there. We could have 15x there and 15 there. Now the simplest thing to do is you need to look at what you've got and say to yourself, how could I get the terms the same? So if we concentrate on the x's, let's eliminate the x. So to do that, what we will do is we will take our two equations. I think what I'll do is I'll keep them in two columns. And we'll eliminate x on the left side of the page. So what we can do is this. If I multiply this equation by 2 and this equation by 7, then you will see that what we end up with is that this is 14 and this is also 14. So 2 times 6 is 14x. 2 times 2y is 4y. 2 times negative 1 is negative 2. Please remember that these are equations. So whatever you do to the left side, you must do to the right side. So for the second equation, I'm going to multiply both sides by 7. 7 times 2, 14x. 7 times 3 gives that 21, which is negative. 7 times 11, 77, which again, negative. Now you can see that these two leading terms, the x terms, are the same. They're both exactly the same. And so in order to eliminate those, what we can do, or we need to do, is subtract them. So if I subtract the top by the bottom, 14 take away 14 is 0. That's why we did it. Now be careful with this step. Top line is 4y. So 4y subtract negative 21. Well, obviously we've got two negatives here. So this will be 4y add on 21y, which is 25y. So be careful with that. Those sort of little things you have to remember about negatives and positives are all going to come back in this unit. So the next part of the puzzle, negative 2 subtract negative 77. So this is negative 2 add on 77, which is 75. Now simply divide both sides by 25. This gives you 1y, which is what we're after, and 75 divided by, 75 divided by 25 is 3. Okay, we're done. We now need to pick one of the equations and use the y value and substitute that in. So 7x plus 2 times the y value. Let me just highlight that for you. Equals minus 1. So all I've done is taken the y value and substituted it into one of the equations. This is now 7x plus 6 is minus 1. If I take 6 off this side and take 6 off this side, this will leave me 7x up there and negative 7, whoops, and negative 7 there. Divide both sides by 7, ends up with x is minus 1. Now clearly, before, we can always check to see if these are correct by putting both of the values back into the other equation to see if that works. One of the questions you might have asked is, why do I have to eliminate x? Well, you don't. You could have done exactly the same question, but instead of eliminating x, we could have eliminated y. So this time, down the right-hand column, what I will do is I will eliminate y, just to show you that it's exactly the same each time. So we've got the same equations. And this time then we're going to look at the y values. What numbers would I multiply the top by and the bottom by, so the two equations, so the y values, the y coefficients, are both the same? Good. You can multiply that by 3 and that by 2. Watch what happens. 3 times 7x is 21x. 3 times 2y is 6y. 3 times negative 1 is negative 3. 2 times 2x is 4. Excuse me. And then 2 times negative 3 is negative 6y. And then 2 times negative 11 is negative 22. Now notice the difference this time. By doing this, I have two variables. One is plus 6y and one is minus 6y. So what will I need to do to those two equations in order to eliminate the y's? Correct? You would have to add them together. So 21x plus 4x is 25x. 6y add on negative 6y is your 0. That's why you did it. Negative 3 add on negative 22 is negative 25. So we have 25x and negative 25. Divide by 25 on both sides. Leaves us with x equals negative 1, which is the same result as we got before. The only difference is we found x first this time, and we'll find y second. Again, using one of the formulas. Sorry, equations, a big pardon. It doesn't have to be the first one. In fact, let's do it with a different one. It doesn't have to be the first one. So I will choose 2x minus 3y equals negative 11, and x is negative 1. Okay, so we're going to take negative 1 and we're going to put it into here, right there. Take away 3y is negative 11. Ooh, nice. Minus 2 minus 3y is negative 11. And remember what we're doing here, we're trying to get y on its own. What I like to do, and I've shown you this before, is take it to the other side, or what I'm actually doing is I'm adding 3y to both sides. So negative 2, these two here have disappeared, negative 3y plus 3y has disappeared, equals 11 plus 3y. I will now take 11 off here and 11 off here. Which is minus 13. No, that doesn't look right. Oh, that's right. This is negative here. This is negative 11. Apologies. So that will be adding to both sides. So, starting again. this is negative 11 here. I'm adding 3y to both sides, so minus 2 on the left side, negative 11 plus 3y here. Add 11 to both sides, this gives me 9 equals 3y, so 3 equals y, which is what we had before. Sorry about that little glitch, but that is what happens now and again. Okay, so